Hi, Assalamualaikum warahmatullahi wabarakatuh. So this is the last video related to one sample sign test, 4 out of 4 videos altogether. And in this video, I'm going to talk about the idea of large sample approximation, which can be used when you have a sample size that is 12 or larger. So here we have a normal approximation to binomial where the test statistic is given as such. And now recall the procedure which you have seen in one sample sign test where the test statistic given here depends on the scenarios that are presented to you. So the test statistic here is not that difficult to be obtained. Basically, you just need to count the number of either positive or negative signs. Now, when the sample size is 12 or larger, you may adopt a different test statistic based on the idea of normal approximation to binomial. And you can see based on this test statistic here, you will employ the value of k. K is the same value which you have seen in the original procedure of one sample sign test. It is just the observed value of the number of signs of interest. Again, either positive signs or negative signs, depends on the situation. N is the sample size, and here we have a continuity correction equals to 0.5 due to the fact that we are doing normal approximation to binomial. We are actually using a normal distribution instead of a binomial distribution, so there is some sort of correction that needs to be considered. We are moving from discrete to continuous distribution, right? And for the purpose of finding probabilities and so on, you are going to refer to the standard normal distribution table, and these have a lot of resources available online. For example, you can go to this website to obtain the table of standard normal distribution. Okay, so without further ado, I'm going to consider the same example which you have already seen in the previous video when the video that I had already explained the original procedure of one sample sign test. And please understand that in actual practice, this example cannot be used with large sample approximation method. Okay, this example is not suitable for large sample approximation method because the sample size here is 11 patients and what it says here is 12 or larger. Okay, so we are going to start off with the process, the first step, which is formulating the null and alternative hypothesis. And according to the question given, it says here, can you conclude that at 0.05 significance level, the median appearance transit time in the population from which its sample was drawn is different from 3.5 seconds. And that should give us some sort of idea on how to formulate the null and alternative hypothesis. So step 1, H null is M equals to 3.5 versus H alternative M is not equal to 3.5. Note that your significance level is given as 0.05 and our sample size is 11. So the next part is to consider calculating the test statistic. Now look at our data. So here is our data, and this is the difference that you need to find for each value in your data set. And of course, you can see that if you consider the signs, so these are all the signs that you can consider, you can see clearly negative and positive. Again, don't forget when you do this process, you have to cross out those that give you value 0 for the difference, and therefore the sample size now becomes n equals to 10. And if you consider the test statistic based on the original procedure of one sample sign test, this is the one that you should be considered, because my positive sign appear less than negative sign, and therefore in this case this is the value of k. K is equal to 1 because positive sign appears only one time. And we are going to use the test statistic as illustrated here based on large sample approximation method. This is what you need to consider as your test statistic. Okay, so here test statistic is just this formula z, and here we have k plus 0.5 minus 0.5 times n, 0.5 set n. So you just plug in the value of k. 1 plus 0.5 minus 0.5, here is the new sample size, equals to 10, 0.5 set 10. Well, if you punch in these values into your calculator, you will get the value of z is about negative 2.2136. So that's the value of our test statistic. Now we need to find some sort of probability in the third step. So here we have to find, the probability of our random variable z taking value that is smaller than or equal to our small z here. Small z here is our test statistic calculated on step 2. So this is equal to probability z less than or equal to negative 2.21. And in order to find the probability here, you need to refer to the standard normal distribution, and you can see that when you want to read the standard normal probabilities, you need to see the figure attached with the table. So basically the figure here is saying the probabilities value given in the table. So these are all probabilities. These probabilities here correspond to the area from this point to the left. So all the areas to the left. So that is how you should read a given table. Well, now if you look at our question here, what we are looking to find is, so based on this mathematical expression here, we are looking to find the value of, so this is the middle point at point 0. We want to find probability that our random variable z is less than or equal to negative 2.21. So this is the position of negative 2.21. And since you're talking about less than or equal, you are talking about this area. So you're looking to find the probability or the area associated with this shaded region here. Clearly, the area that you are looking to find is similar to the area given in this particular table of standard normal probabilities. Therefore, you can just simply read the value of z right here without having to do any sort of adding or subtracting values from the table. Yeah, so you just read z, the value of z, negative 2.21 So the probability here is about 0.0136. Okay, so that's what we're going to write down. The probability of that is about 0.0136. So this area equals to 0.0136. Okay, now we are done with that. Next, on the fourth step, what you need to do is you need to make some sort of decision. So probability z less than or equal to z here is obviously less than or equal to alpha over 2. So this is the condition that you need in order to reject H null. Okay, so clearly what we have is 0.0136 is less than or equal to 0.025. Therefore, you are going to reject H null. Okay, next what we can do is we can come up with a conclusion, and basically the conclusion is just looking at again at the problem posed in the example. So here we can say that there is enough evidence to say that the median appearance transit time in the population, well, again, it's just copying the last line of the example given. Okay, so the median appearance transit time in the population from which its sample was drawn is different from 3.5 seconds. Okay, so now if you compare this approach with the approach you have seen in the previous video, you please remember that in the previous video what we have done is on this fourth step, what we did was we find the probability our random variable k is less than or equal to k, given that sample size is 10 and the probability is 0.5, and we decide to reject the null hypothesis again by following the same idea, because this value here is less than or equal to alpha over 2. Remember that we got this value equals to about 0.0108, and this is less than 0.025, and so you reject H null. So that is just to give some sort of perspective on what we did before and how was that different to what we are doing here right now. Okay, so that's it. And maybe before I end this video, I would like to talk about the alternative approach to step 4. Okay, hang on. So again, instead of using this, you may want to decide whether you should reject or do not reject H null based on the p-value approach. So what is a p-value approach? Okay, so in the p-value approach, you need to find the p-value, obviously. So in the p-value approach, remember, when p-value less than or equal to alpha, you get to reject H null. So in this case, p-value here is this probability that you get times 2, because you are having right now is a two-sided hypothesis testing. So the probability here, the p-value is about 0.0272. So clearly 0.0272 is less than or equal to, what's your value of alpha? The value of alpha is 0.05. Therefore, you can reject H null, and of course you will arrive at the same conclusion. Okay, so that's the p-value approach. Now let's talk about the traditional approach. Okay, so for traditional approach, you are going to compare your test statistic with the critical value. So again, traditional approach, the comparison is based on test statistic versus critical value. So here is your test statistic. Okay, so here is test statistic about -2.21, and you need to find the critical value such that the area is 0.025. Why the area is 0.025? Because alpha is divided by 2 due to the fact that you have a two-sided test right now. How do you know it is a two-sided test? Based on your hypothesis, the construction of your hypothesis. Okay, so basically, imagine having a standard normal distribution. So here is 0.0 in the middle. So alpha over 2 is to be divided accordingly. So here there will be an area of 0.025, and here is also the area of 0.025. And you need to find the critical value here, over here, and that side. And it is simple to find this critical value on this side based on the table given here, because the table given here is related to the area to the left. So we need to find what is the value of z here on the horizontal axis. Go to the probability area in the middle here and find where is 0.025. Well, it is not there actually, because the value of 0.025 here is associated with -1.96, which is actually further down below. Okay, well, try and get your complete table of standard normal probabilities, and you'll be able to find this is the value of z associated to the area of 0.025 to the left, -1.96, and over here is 1.96. Okay, so so you can see that critical value is just plus minus 1.96. Okay, let me just write that properly here. Okay, so that is -1.96 and 1.96, and you can see that our test statistic -2.21 must be somewhere here, so it falls into the critical region. Another word for this area is the critical region. So -2.21 falls into the critical region. Okay, so what we can do is, based on this observation, we can reject H null, and again we shall arrive at the same conclusion on step 5. Okay, well, I think that's all from me related to the idea of large sample approximation in one sample sign test. And to end this presentation, I would like to share some of the references that I use in constructing the materials for the videos related to one sample sign test. And well, if you have time, you may want to visit all these websites here, or maybe obtain some of these references. And I I think that's all for now. Thank you very much for watching.